All right. So far, 3B, part B of 3A.3. We reviewed what we already know, right? And now we're putting in what's new. The new piece is theta is given. I can find anything. Make sense? Yes. Yes, of course, Michelle. That makes sense. Perfect. Yes, makes perfect sense. Thank you. There we go. We just need an example to see how that works. Does that make sense? So let's look at an example. So it says here, given an angle, measure of 4 pi over 3. So given the angle of 4 pi over 3 in standard position, so this is our 4 pi over 3. That's the angle. This is our initial side, and it's going, okay? 4 pi over 3 in standard position in a circle with a radius of 5. So we know that the radius is 5. We know that our theta equals 4 pi over 3. Okay? So now that I'm here in the standard position, can I calculate x and y? I surely can. Huh? Nope. We're not picking up a calculator. Calculator is not in our lane right now. You are the calculator. Okay? Yeah. If you want to convert it, 1/8 over pi, yeah. Why do you want to convert it? But yes. All right, so the reference angle here. Your reference angle is going to be, we represent it with a little tick mark. Theta equals pi over 3. Because 4 pi over 3 is just, 1 in from pi. Because you have a radius and a theta.
No, but like, how are we supposed to do 5 times the cosine?
So this is pi. How far is 4 pi over 3 from pi? Does that make sense? This is 3 pi over 3. Let's put in that. So how far am I from here? Pi over 3. So I know that this little distance, that's my reference angle. That means that this is equivalent to me using 60 degrees. Agree? Yes. We're about to. I'm about to show you. All right, trust the process. All right, so up first is finding our x. Our x equals r cosine of theta. So x equals, what's our radius? 5. And our cosine of, and we're using 4 pi over 3, which is the same thing as, what's my reference angle I can use instead? Pi over 3. Huh? Oh. Okay, so x equals 5, and then the cosine of pi over 3. So cosine of pi over 3, we just did it, is on the other side of your paper, right? So if you got to think of it in terms of degrees, you can, but it's not necessary because we should be comfortable with radians. But you're asking yourself, what is the cosine of 60? What is the cosine of 60? 1/2. That's why I said you have to know these values. Okay, if you couldn't remember them, then you always have the triangle to draw out. 1, 2, square root of 3. Okay, so therefore x equals 5 over 2. Because 5 times 1/2 is 5 over 2. Oh my gosh, we did it without a calculator. It's crazy. Did you survive? Mm-hmm. Mm-hmm. Now we got to do y. So y equals r sine theta. So r is 5 sine, and again, we're using pi over 3. So y equals 5. And what is the sine of pi over 3? Is what? No, 2 over 3. 3 over 2, that's not that. Square root of 3 over 2. So our y equals 5 square root of 3 over 2. Okay? Because I'm in quadrant 3, what are they? They have to be negative. Does that make sense? So then and therefore, that's what these three dots mean. Then and therefore, our x comma y that satisfies this equals -5/2 and -5 square root of 3/2. I'm writing it so you can see it. Why would I? Not. It's the last one as y'all's. Anyway. All right. How do you feel? Talk to me before we go on. You have to know your unit circle. Like you have to know them. Suck it up, Buttercup. You can just leave right there. Perfect. Yes. Okay. You're not doing it yet. You're doing number 10 by yourself. Number 10. We're not there yet. All right. So number 7. I said calculate number 10.
I'll hire an army of boys.
Thanks. All right.
That's the joke, man.
Oh man. Anyway, okay. All right. This is escalated. Here we go. Number 7, cosine theta. Cosine theta equals -1/3. Okay. So what I want you to do is, I know that we've learned something new, and it typically what happens is when I show you something new, you guys forget what we just did. Okay. So we're gonna pause and we're gonna make sure that we remember, if I give you the theta, if I don't give you the theta, but I give you the trig ratio, can you still solve my triangle for sine? Okay. Yes. Okay. Here you go. Cosine theta. This is my little tidbit for you. And then you're gonna go fly, little birdie. You gotta. Cosine theta equals -1/3, which means you have x over r. Go. Good job.
Why do you use the non?
Okay, so let's take regroup. So here we have -1/3, which lets us know that yes, this is in quadrant possibly number 2 or quadrant number 3, but according to this, we're in quadrant number 2 because our x is negative. Makes sense? All right, so we're gonna have to use x squared plus y squared equals r squared. And in order to find sine, we need our y. So we have y squared equals r squared minus x squared. So y squared equals 3 squared minus -1 squared. So y squared equals 8. So y equals the square root of 8. 8 is different than the numbers we've been working with so far. 8 can actually be simplified. 8 can be simplified to 2 square root of 2. Does anyone know why 8 can be simplified? Because 8 is made up of a perfect square. Square root of 8 is the square root of 4 times the square root of 2. Is it not? And what's the square root of 4? 2. So you can simplify 8 down to 2 square root of 2. So that is your y value. Okay. Now that you have your y value, can you easily tell me what sine theta is? So sine theta, which is y over r, my y is 2 square root of 2, and my r is 3. So my sine theta is, the sine of theta is 2 square root of 2 over 3. We do. Don't worry, you'll get so much practice on your Pearson assignment. Okay, yes. Where were you at just then?
I thought I got
That's
it
like
right.
me when I was. You were right.
Why did you do 2 squared 2?
Because square root of 8 can be simplified. You do.
Right, wait.
I did. 9 minus 1 is 8.
You know what? You're right. We got this.
No, parentheses first. A negative times a negative is a positive, and then you're left with 9 minus 1, which is 8.
Wait.
You,
I need some water.
we're not adding, we're subtracting.
So I'm saying, how is the square root of
You have to dump all of that.
It is the simplified form because you evaluated the square root inside. So square root of 8, guys. Square root of 8 is made up of a perfect square. So you evaluate the perfect square. So the perfect square is square root of 4 and square root of 2. Well, square root of 4. So when you evaluate it, square root of 4 is what? 2. And then the radical that I can't evaluate is left on the inside. So you just simplify the radical. Now, this would be helpful. Let's say 3 had been a 4, right? And then I could have reduced from there. But 3 is prime and I can't do anything else. So that would be your form. All right, on part 8. So on part 8, we have example, I'm sorry. Find all values where theta is greater than or equal to 0, but less than 2 pi, where cosine theta equals 0. Okay? Cosine theta on your unit circle. This is just describing the full unit circle. Does that make sense? So this is describing your full unit circle. So on your full unit circle, you want to know when cosine theta equals 0. Cosine is which variable? Cosine is which variable? The x. So this is just simply asking, going around your unit circle, when does x equal 0? Okay? Where does x equal 0 at? At what? What are my values? So at 90 degrees, which is pi over 2, and 270 degrees, which is 3 pi over 2. That's all it was asking. Okay? So the domain restriction is, well, your theta restriction, not domain, I'm sorry. Your theta restriction is telling you that to look at the entire unit circle. Does that make sense? Cosine theta is telling you to only look at the x coordinates. So when is your x coordinate 0 is all it was asking as you go around the unit circle. Okay. If I asked you in another way, what if I asked you for when sine theta equals 0? What will have been my response? Y equals 0. So then therefore, what would be my angles? And 0. You have to actually include 0. Okay. And the reason why you have to include 0 is because it says equal to. I wouldn't include 360 because it says what? Strictly less than. But I will include 0. Does that make sense? So paying attention to the theta restrictions is going to be important. All right, number 9. Number 9, we're now having more restrictions on when we are evaluating. So it says that tan theta is 4 over 3. Cosine theta is less than 0. Find the sine theta and cosine theta and the coordinates where the terminal side of the angle intersects. Okay, so we have to determine where things are positive and negative. So cosine theta being less than 0 means that we're looking for a negative cosine. Does that make sense? Okay, so if we, as we talked before, we talked about all are positive in quadrant 1, only sine and its reciprocal are positive in quadrant 2, only tangent and its reciprocal are positive in quadrant 3, and only cosine and its reciprocal are positive in quadrant 4, correct? Okay, all all are positive. Okay, sine only, tan only, cosine. So when I'm looking for possible, I can't even talk, possible quadrants where cosine is negative, my possible quadrants for negative cosine are in quadrant 2 and in quadrant 3. Does that make sense? Because otherwise, cosine is positive and positive here. The other thing that you're looking that translates to is you're just asking, when do you have negative x's? And my x's are negative in quadrant 2 and in quadrant 3. NEG for negative. NEG for negative. All right, so now we are either in here or here, and then it says that your tan is positive. So now, focusing on that, out of these two, who's my winner? quadrant 3, because that's where I satisfy both requirements. Tan is positive in quadrant 3, and my cosine is negative. So my angle has to be in quadrant 3. Does that make sense? Okay. Because I'm in quadrant 3, that means my final x and my final y both have to be negative. Okay. And what do you mean? We're just finding the radius and the sine and cosine. So tan theta equals 4/3, which means that my y and my x are given. So we have 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. 25 equals r squared. And therefore r equals 5. This is going to always be true when you have 3, 4. They're called Pythagorean triples. Does that ring any bell? 3, 4, 5? Pythagorean triple. Yeah. If I know that my sides are 3 and 4, then my hypotenuse is automatically 5. You should have did it in geometry. Yes. All right. So now that I have everything, can I determine sine and cosine? Sine of theta equals and cosine of theta equals. They are both going to be negative. And why are they both negative? It's in quadrant 3, and my x's and y's are negative. Okay. So my sine theta here is -4/5, and my cosine theta is -3/5. Okay. That's what it means to pay attention to the restrictions. Okay. All right. Last part is on you. Calculator is allowed. So using the fact that we know that x equals r times cosine theta and y equals r times sine theta, find your cosine, find your x and your y for this angle. Your 14 is your r. Yes. No, Randy. When we come back from spring break, we are gas. What is it? Pedal to the metal. Yeah. What is it? That okay. I was like, because I was going to say gas pedal, and I didn't think that was right.
Was the angle of the both 25?
The angle is the 25. Your theta is your 25.
Yeah.
Yes. That's why.
Same with I do this piece. Different degree earlier.
What is your angle in? What is your angle in? So what is your calculator going to be in? Okay.
I'll start schooling soon.
Decimals is automatically in radians. So you got to click on the little tool on the.
I need 6 college credit. Everything.
All right. So this should have been our favorite problem of the day, because it's just, like a little plug and chug here, right? So our x equals our radius with this 14 cosine of our angle, which is 25. Our y equals our radius times the sine of our angle, which again is 25. I'm going to go to my handy dandy Sylvie. Her name is Sylvie. But yes, we're going to go to Sylvie, and we're going to make sure Sylvie is in degree mode, because my angle was given to me in degree. Is she currently in degree mode? No. So I'm putting her in degree mode. I'm going to round it, because mostly it's solved in radians, to be exact, to be precise. So I put mine in 3 to round for me, because on Sylvie you can do that, but on y'all's little Desmos, you're just stuck out there. So we have 14 cosine of 25. Boom. And we have 14 sine of 25. Bam. How'd we do? So we know that x equals 12 and 688 thousandths, and y equals 5 and 917. And those were the coordinates that would satisfy where they should drill. And we're done. Okay? We did approximate. We wrote 14 cosine 25.